You should
Это.
stop screen share.
Дякую.
Yeah, sorry. Yeah. Okay. So let me try. No, why? What is happening? Participants, I can see my whiteboard. Okay.
You're sharing the screen.
Yeah. So can you see what I'm writing or not?
Yes.
Yes. So there is a very simple and trivial theorem, and trivial theorem is like this. So imagine we have some function u, which maps strings to strings, and then we have a complexity function cu, which of every x is just the minimal length of in a preimage, minimum length of p, such that u of p is x. And we have also a set nm, which is the number mn, which is the number of strings x, such that cu of x is smaller than some m. And the question is, general question is, it exists for any partial function. General question, trivial question is there a machine M that computes all nm having Oracle access to u?
To you?
Sorry. I am completely wrong. To see you. And the answer is negative. Not.
And access to CU means you can
give some string and get some information
and the
about
value,
complexity.
and you can decide if it is correct.
Yeah. And here is the simple idea why this machine could not exist. Because imagine that machine M takes some number M and gets some answer for nm. And in this case, during this computation, it uses values of some cu of some strings, z1, zk.
I'm sorry, M runs in polynomial time or what?
No, now it's not important. It will be important, very important later, but just now there is no machine that computes all nm having access to cu, and a weaker form is just for all u. So now machine should be work for every u, and we will prove that it's impossible. And let me explain the reason. So if the machine has input m and computes nm, it should ask some value of complexities of some strings. But there is a simple way we can change nm, leaving these things untouched. Why? Let's take some string z of length small, something p of length smaller than m, and take a very large z, which is not so large that is not among the z1, zk. And now if we change u and say that u of p is now defined, imagine it were undefined, and now it becomes z. Then the complexity of all other strings remains unchanged. We just have a new description for a new string. But in this way, we get a new string of small complexity. So we need, first, we take a very large Z, so it has high complexity, and then we make the complexity small, so the number nm increases. So I think this was, in a very simple form, in a trivial form, some idea used in the proof of Losha.
Sasha, I don't think you are right. What do you assume about U? It's just some function.
No, we want to construct U, which is not good.
But assume that nm is already as maximal as possible. How can you increase
No, it? You're right. We should assume that U is undefined
on the empty string.
On, for example, empty string or on some short string. No, since we're now trying to construct U, we can start just with completely empty U. It will make the proof ridiculous, but still formally valid. Or we can start with U, which is a real universal decompressor. It's somehow undefined somewhere, and so we can take M, which is bigger than this place when it's undefined, and use this M for this kind of diagonalization. So this, I think, is explanation what to do if we have just one, if we need to beat one machine M. And so is it clear? Коля, это понятно?
I think that the proof works, say, for m equal to 1, right?
Yeah, we can start with U, which is an empty string, and we can just add this U, additional define U on empty string, and M is equal to 1.
So actually we can't compute even n1.
Yeah, no, we cannot compute even n1. For a given machine M, we can provide U for which machine incorrectly computes M1. Yeah, that's you are
right.
completely right.
The idea is clear, but I don't understand the claim. You say that the claim holds for all U, but
No.
then you say U is undefined on short string.
No.
Sorry.
No.
So let me clarify. So the claim is that there is no machine M such that for every optimal decompressor U, M, given the oracle access to the complexity function of U, computes the number of strings.
So
complexity less
the
than
words
M.
for all U were requirement for the machine M. So
And
it
then
makes
to
our
refute this,
task
we give
easy.
an example of U. I mean, actually,
I
start
see.
with some U, we
I
take
see.
a U
So-
for which it's supposed to work, and we modify it. Then for this modified U, the answer is wrong.
In search of a bad U, we start from a trivial nowhere defined function and then add
Change it
some.
if necessary.
We start with some decompressor which is not defined on the empty string.
Okay, we can just start with some other function U which is not total, and then take M greater than the place when this U is undefined.
Yeah, I see.
Yeah.
Okay.
So this is completely trivial. And also there is other thing which is also more or less trivial. So we say that for every there exists some U such that no machine can serve it in this sense. So it's a kind of stronger result. So there is a U which no machine can compute this function in M. The difference with what Lyosha says, that Lyosha wants U to be computable. And we don't have U computable, but still we can make diagonalization in a standard way. So is it clear what we did and what we are claiming to do now? Коль, скажи что-нибудь.
It's clear.
Clear.
Right.
Okay. Maybe now it's clear for you how to diagonalize.
I mean, how to prove that there is one U?
There is one U. So we need to
I think
to
so.
beat all the machines.
No, in the usual way, we enumerate all the machines, as
Yeah.
you said, and then for every machine, I mean, we build U step by step. On ith step, we take ith machine and choose M so large that nothing was untouched yet, and just we make the same trick. So initially M, we choose large M, initially M.
So we will beat these machines on some M1, M2, M3, which will grow.
Initially NM is very small, much less than 2 to the M, so we have enough space, enough room to fool the current machine.
No, you can have, if we start with empty U, we just make the answer of machine, first machine false on some M1 as described.
Mm-hmm.
And for that we may need to define U on empty string. Mm-hmm. And then we take M2, which is bigger than an M1. And so we can still, and we take a string which is longer than M1, and we'll for the next machine we use this string to make complexity smaller, to make the number of strings of length M2 at complexity at most M2 increase it, not changing things about M1. So we need intermediate strings of intermediate complexities, of intermediate length, to use as new places for U.
So once again, we are trying to show it for a not necessarily optimal U.
Not necessarily optimal and not necessarily computable. No, we can actually start with our standard optimal decompressor and then only increase it, making the complexity smaller. So it will give, this is possible, but this is not what we want. The main problem is that U is not computable.
I tried to understand why this U is not computable and understood that there is a subtle point in our reasoning. The subtle point is that actually the current machine, machine MI, cannot hold at all, and we do not. In that case, we do not know whether it actually holds or not holds. That's a problem. Why we can't actually build such a computable.
Yeah, but if our machine is polynomial, and even if it's total, and it's not a problem.
Right.
In this case, actually, we can construct a computable U, because our process will just define our U on longer and longer strings in a kind of computable way. But this computable U won't be optimal.
So can we understand this once again? So you start with U, which is not defined anywhere. So the complexity like of any string so far is
infinite.
So you run
I send this
M1 on the input of length M1, and then you just answer that the whatever Oracle queries it does, you say
for every query I say that the complexity is infinite.
And then okay, these strings will just forever have complexity infinite. You decide in advance, and
Yeah.
whenever the machine stops, either it outputs something non-zero,
Then we
then
don't
it's fine.
care.
Or if it outputs 0, then we say, okay, but really there is some longer string that
Very,
has
very
complexity.
long string whose complexity is 0,
Okay, then
which
we
was
start
not
with
yet asked. Then we start with M2. We take M2 bigger than this M1.
yeah.
No, and bigger than the length of potential string of the 0 string. So now it's trivial. But
Yeah, and the
okay.
string that we have used for M1 so that we can make there is a room to make some string of
No, actually,
complexity
I think
less
we don't
than
need to make M2 bigger than the string who already has complexity 1. It will have complexity 1, so why not?
yeah.
Just we look what imagine that you never change anymore and see what M2 does, and then either change or not change the U to make the answer incorrect. And of course, we should not disturb the previous answer. So some strings should have complexity infinite, and then it will be and some.
Yeah, so in any
So we
moment,
cannot define
most of
make
the
use
strings
them.
will have complexity infinite. Some
Yeah, in
strings
this
will have
construction.
complexity less than M1,
Yeah.
one maybe less
Yeah.
than M2 or something.
Yeah. So this is a computable construction, but of course it doesn't give an optimal U. And the idea to get an this I'm almost finished in our what we understood, and there is only one thing which I can add. So somehow, what terms of what does it mean that we want to make U universal? Actually, we can think that there is another process which decreases the complexity of different strings, which happens independently of us. It's a game. And then we also can decrease the complexity of some other strings and complexity function. And then we want to beat all the machines. And this is what is called Muchnik game construction for complexity. So every complexity question, whether it's possible to construct a complexity function with some properties, more or less is a game. So the enemy decreases the complexities of strings, keeping some quantitative restrictions. And we also do the same. And the final function is the minimum of our function and his function. Or we can decrease the same markers, the same numbers. And ability to win in this game is just the ability to construct a complexity function with some property. This was General Muchnik's observation. And Lyosha, I don't know, rediscovered it or used it, but I guess it's the same idea.
Yes.
Yes, you rediscovered or you knew it?
Of course, it is known about game. Yes.
No,
So.
I should say something in Russian because it's a quote. По-моему, это Гаспаров кого-то цитировал, какого-то философа, а философ сказал, что известно немногим. So when you say it's known, it doesn't mean anything.
Okay. And about that game, I should say yes.
Yeah.
Okay.
Okay, so now the cat's experimental animals are finished, and if something which is not clear, just ask.
You should stop share, and I should start to share. Okay.
Okay, but if there are some questions, is it clear what we said with Sasha? Because if it is not clear, anything else will be unclear either. So,
Okay.
okay.
I think we should start with this game. Okay, we forgot about complexity. Just consider the following game. Assume we have some polynomial machine M with the input n, and we have some function O that is equal initially is equal to the length of x plus some constant. So this is an upper bound Kolmogorov complexity, and during the game, this value can be decreased. So Alice wants to make m on this input is equal is not equal to an m with this oracle O, and Bob wants the opposite. And the move in this game is to make the value of if of x is greater than k, then the players can make it equal to k, and for each such move, there are budgets of Alice and Bob, and we assume that Alice's budget is 2 to the k minus 1, and Bob's budget is 2 to the k minus 2. So
For each k.
for every k, yes.
So if you take k equals 2 to the power m, Alice and Bob can change 75 persons of strings.
Sorry?
Suppose consider a particular value of k. Alice can change a half of words, and Bob can change a quarter.
Yeah, yes.
No, but it's not the quarter of words. It's just the number of strings which are declared simple.
Yeah.
There is not. We don't start with k-bit strings. There is no universe. Alice can take any string and declare it as simple. But what it cannot do is to have too many of them. So it's
Yes,
not a
you
fraction
can-
of
Alice,
all
for
k
example,
words.
can
This
say-
was a wrong.
Alice, for example, can say the complexity of x is k at most 2 to the k minus 1 times. Each time she claims that the complexity of a string is k, she pays $1, and she has at most 2 to the k minus $1 for that.
Yeah, but also if she paid $1 for some string to be of complexity k, then the enemy can pay some more to make it complexity k minus 1. So Alice Alice can decrease the complexity and Bob, but not increase.
I have a question. Do we assume here that M is total machine?
Yeah, total polynomial time, even polynomial time machine. So yes.
Even
total.
polynomial time.
Yeah. Hey, it's not very important, but so total is enough, but this is only polynomial. Okay.
And there are no restrictions on axis.
It's not clear what's the rules of the game, right?
Yes, because
okay.
move is to change the value of O of x at some point.
Complexity, value of complexity. We don't explicitly define the universal decompressor. We deal only with complexity function. Initially, it's x plus O of length of plus O of 1, and then both people decrease it.
Okay. The rules is the following. If one of the okay, we have what Alice and Bob wants, and if in some moment one of the player the value of O is such that one of the player do not want it, then the player must do some move. And if he or she cannot do it, cannot move such that the value is changed, then he or she loses.
Yeah, let me repeat what Muchnik explained many times about this game. So we can look in different ways. One of the ways is just that Alice and Bobs can spontaneously move at any moment when they want, and they look only on the final limit values to decide who wins in this infinite game. But of course, if the current position is winning for Alice, there is no reason for Alice can postpone all the move because the move are more or less commutative, and if the Bob does something, he can do it.
I don't understand the following. Actually, machine M machine M is just a deterministic polynomial machine without any oracle, yes?
Yeah, no, with oracle. Is this oracle O?
This oracle O.
Yeah.
So what is the move? Suppose I change the value of O of x for very, very large x.
Yes.
Such that M just cannot ask about it.
Yes.
It is always possible.
Yes.
Yeah, but also the enemy can change value of O on some string which is accessible to X, to machine. So, and then Alice should react somehow. Now machine asks different things and gives different answer and so on.
Mm-hmm. So difficulty is one player can change the behavior of M, changing values of X is small enough to be asked.
Yeah.
If no, it seems that players can change very large strings, and it changes right-hand side of equality and does not change the left.
Yes.
But wait, you are talking about oracle machines. M is an oracle machine.
Yeah, oracle.
Why don't you write O? I see.
Sorry. Yeah.
It is written at first line.
Леша пишет на своих старых заметках, что слушатели не любят, по крайней мере, некоторые. Ладно.
Okay. Is it clear now the rules? So we have some oracle machine. Yes, and the players change this oracle, and okay.
Okay. Now it's clear.
Okay, and so now we can prove this that Alice has a winning strategy. I think Sasha Kazachinsky understand why.
Not really. Not really, because there is some. So now budget is more or less complicated. We have this for every k, and so we have not one budget, but a sequence of budget for each k. And
okay. Let us first consider this point that Nikolaevich mentioned about the strings of very large lengths. So if we ask, okay, sorry, let me just try to prove and prove.
And also it is not clear. Alice can win all the games for all M?
No, just for one.
For one, okay.
Okay, proof. Okay, the first case, if consider the same game, where Eddie's budget is equal to Bob's budget. If Alice wins in
For
this
every K.
game,
For every K.
for every K, yes. If Alice wins for this game, then of course she wins in the initial game. So this is simple. So we consider now we consider the case that Bob wins in this.
Now the cases are considered just theoretically. We know that either one or two. We will not postpone the discussions how we know this. We just consider it.
Excuse me, when we consider these two cases, do we assume that M is fixed?
Yes.
M is fixed, yeah.
For instance, M is 0.
Yes.
Okay.
Oh, if M is 0, it is very simple that Alice wins in this game, right? Because
but why it's simple? We know that an M is 0 then.
No. You ask about M. For machine is if a machine is constant, then Alice wins because she can change an M.
No, but still Bob should no. If Bob doesn't do anything, just the function is big, and there is maybe there is no strings of length smaller than of complexity smaller than M. So the answer 0 is correct. Why not?
Sorry.
No, Kolya asks, what if machine gives always answer 0?
Yes.
And M can be also 0.
Initially.
For some M.
Initially, yes. And then
Alice doesn't win the game. That's what I'm saying.
So,
that's what
Alice has budget for M. For K is equal M. And Alice just increase an M to 1.
Yeah. But Kolya says that you said that in this case, Alice doesn't do anything.
No.
Maybe it need decrease something.
Yeah. Okay. And let us return.
Что-то я не понимаю, я по-русски скажу, Леш. Если M равно нулю, то есть независимо ни от чего, NM равно нулю, правильно?
Машина.
Нет, не NM. Нет, мы не можем сказать, что NM равно нулю.
Почему не можем?
Нет. Если M равно нулю, то строк проще нуля не бывает. Поэтому действительно, если машина дает ответ 0, она права. Но если надо взять M, которое не равно нулю.
Конечно. M больше нуля, да?
Короче, мы фиксируем любое M больше нуля, да?
Да, хорошо.
Sorry, just about budget, I want to ask one thing. So if we decrease function from 10 to 5, for example, we pay only 1 unit for 5, or we also pay 1 unit for 6, 7, 8, 9, 10. How you define this?
Only for 5.
Only for 5. Yeah. Good.
Yeah, okay. You catch me. M is rather.
We have a limit on declaration of complexity values. So complexity values k can be declared this time by Alice and this time by Bob.
Yeah. But then it can be decreased further, and so the number of strings of money is already paid, but strings become even simple because use his other budget for other smaller complexity to decrease it further. This is quite possible.
Yes, we take into account all complexities less than m.
Yeah, and the total budget is just twice more. It's not a big deal.
Okay. Okay, should I return? Okay.
Sorry?
Should I continue the proof?
Sure.
There is, yeah. Okay.
You
okay.
can stop on the second case when Bob wins
yes.
the restricted game.
Then Alice can do the following. That you says that her first move is consider some string y such that y is very large. That is so m does not cannot use this y in its works, and after this use the strategy of Bob in this in the game with the same budget.
And because Alice has bigger budget, she's still able to follow the strategy
Of Bob,
yes. Alice has bigger budget, so he.
No, but
she is able to imitate Bob's strategy, and the choice of initial string guarantees that the behavior of machine M does not change.
Still there is something which I don't understand. So do you understand correctly that the initial value of our function O is part of the game? It's it's an initial condition of the game. It's not part of any strategy. Yeah?
Yeah.
But still after the Bob Alice changed the function even very far away. Technically we have a different game. So why Bob still have the winning strategy?
We need to say something like this, that position in the game for very large strings does not depend what exactly strings we declare to be simple. It is only important the number of this game.
Of the strings.
Of the strings, yeah. So, yeah.
Just say it again. Maybe in Russian.
The machine M cannot distinguish large strings.
Machine M cannot distinguish. But Alice and Bob see entire thing now. And as it was explained, the O function, initial value of the O function, was some initial part of the definition of the game. So strictly speaking, we have a slightly different game, and we need some explanation why it doesn't matter.
По-русски. Нет, еще раз. Но вот это то, что позиция в игре, она не зависит от того, какие конкретно длинные строки мы назвали простыми. К простыми, скажем, для каждого К.
So you want to say the following thing, that we can group the positions in the classes of equivalence when for big numbers, it doesn't matter which strings have simple complexity of this complexity, only how many of them there is, because they don't change the behavior of machine M, and so and they don't behavior the accounting of the budget. Just but now we still have one. Still something changed. We have a new string.
Yeah.
No. So we use a strategy of the Bob in initial position. Yeah. Without this new string added. Yeah.
Yes.
But imagine that this strategy of the Bob, for some reason, tries to change the complexity of this string.
When we say that we change.
Bob can change only a fraction of long strings.
No. I agree that only the number of the exact type of long string is not important. But we still have one string which is simple.
But
it's not in the other equivalence class.
We can assume that this this is stupid move, because we make it simple, M simple, and after this we again make this string also M simple, right? We say this. We can say that this is forbidden. The stupid moves are forbidden because.
Слушайте, что-то я перестал. Вы что-то обсуждаете, какие-то сложные вопросы, а я совсем простого не могу понять.
Да. I'm translating. Vishchatin can't understand something very simple.
Okay, I can try to speak in English. Okay. So you say that we assume that Bob wins, but if Bob wins, then M is equal to M, right? But how Alice can win if she uses Bob's strategy, she achieves completely another goal.
But it uses Bob's strategy in a different game. When it starts with a secret move, declaring some string very simple. And then she plays as this move doesn't exist, and she doesn't show this move to Bob, and she plays an original game. This is the idea. But the question is how this ignorance of Bob can be maintained.
That in the new game, NM will be one larger, right?
Yeah, so I can try to summarize. So you can actually think of the game that, well, you have, so basically there are just, that the only strings that you really care about are of length at most 2 to the m. Those are strings that our machine can in principle look at. So all the other strings are really not exist. I mean, so, and you can imagine that the game is really, you have the number for every k, you currently have the number of strings of complexity k, and you are interested in the sum of these numbers for complexity up to m. But what the players can do, they can either just increase one of these numbers, nk, the number of complexity of length k, and you have to pay $1, and you have at most, Alice has at most 2 to the k minus $1 for that complexity. But the other way you can increase this number is you can actually decrease complexity of one of the strings of length at most 2 to the m. Then you can indicate, I do that in another way. I decrease the complexity of a string that of length at most 2 to the m. And then, I mean, and you can be, your motivation to do that might be that this way you can, in principle, change the how the machine works now, currently. So this means that what Alyosha tries to say, that initially Alice can just increase, this number n0 and set it to be equal to 1, and then you just play the same, use a strategy pop as if n1 is still 0, but I mean, it doesn't matter. It means
but
that
let me say there is still a small problem. The problem is that Bob is the strategy of Bob is applied to some imaginary game when this big string, which is now simple, doesn't exist. And theoretically, it's possible Bob can also change the string.
But I mean,
then Lyosha says that since strings are long,
where I gave you a modification over a game where really you don't even indicate what the for strings of large strings, you don't even indicate which strings you make simple. You just say, okay, I just increase the number of simple strings.
Yeah,
no, but it's not possible because then in our original game, both players have the ability to increase an m by declaring some long string simple, and you have to prevent both of them doing this.
And I'm saying that I consider another game where you don't have to declare it, which string exactly you make simple, or you can, if this you can only declare that this specific strings became simpler if the string is not long enough.
And for long string, we still keep of them how many are simple. And you say that if you need to increase this number and decrease the complexity, you always have a suitable string, so there is no problem of exhausting the reserve.
I mean, you can increase the number of simple string by using a long string, or if you also want to in principle influence how the machine works, you can actually say, okay, I actually make this specific string simple, but this is only a short string. You can only do that for short strings.
Mm-hmm. Okay, so now it seems that it's not completely trivial. What does it mean that Alice used Bob's strategy? It should use it in a modified strategy, hiding something of this simulated Bob. But still, Sasha somehow explained that you can really hide this.
Oh, the modification of the Bob strategy is that just Alice plays as it, I mean, you can imagine that basically in this game, you have for each possible value of complexity, you have the number of strings of that complexity. And then also the current values of complexity for short strings. So the Alice makes a move which just increases n0, the number of strings of complexity 0.
No,
but using a long, I mean, not indicating which string exactly. So then she uses a pop strategy as if n0 was 0, but
no, Sasha, I still don't. Now I start worrying. Okay, we don't care which strings are simple, but the number of simple strings is in the game.
Yes.
No, I mean, still, if you want to increase nk by 1, you have to pay $1, and you have at most 2 to the k minus $1 for this operation.
Yeah, but still, we apply Bob's strategy with which situation? when this number is increased or an original one?
We apply Bob strategy when n0 is as if n0 is 0. So we play as if n0 is 0. Well, I mean,
So
what is n0? Is the number of the current, I mean, is the like a counter of the strings of length 0 according to the current value of O.
Yeah, so
But
you apply
always,
new situation.
huh?
You apply Bob strategies in a model in an unreal situation when actually this number is one small.
So I apply it in a position when n0 is 1, but I use it as if n0 is 0. So for every position in that game, I turn it into a position where it was actually less by 1. So I have a position in the game where in particular I have the value of n0. I decrease it by 1 and I apply the old strategy, decrease it by 1, subtract 1 and apply the old strategy of Bob. That's my modification of Bob's strategy.
So Lyosh, it's what you are saying, yeah?
Yeah. That's another word that it is not important what exactly strings we can list.
Сейчас, Коля, понятно это или нет?
Нет, ничего не понятно. Во-первых, если я правильно понял, Леша утверждает, что 2 в степени k минус 1 можно заменить на 2 в степени k минус 2 плюс 1, так?
Да, это правда.
Да. Тогда я очень...
We don't use, it's enough to have 2 to the k minus 2 plus 1. We just want a list budget to be one unit more.
Now, what I don't understand yet, Bob uses Alice's strategy, right?
No, Alice used Bob's strategy.
What happens if Alice's strategy...
No, Alice used Bob's strategy. You mean otherwise. Alice used Bob's strategy.
Alice used Bob's strategy. Okay, but what happens if Bob makes a move that decreases the complexity of that secret string?
It is what we discussed. There are a lot of strings, and with a very large string, with very large lengths, and the number of such strings that are simple and have very large length, it's only important. It is not important for the position in the game. What exactly the strings?
So let me say.
We can say if Bob wants exactly this string, he can change. He can make simple another large string. Say that this string will be simple, and this will be the same situation in the game.
No, just Kolya. Bob doesn't see the secret string because we apply Bob's strategy in a simulated game when the string doesn't exist.
But what happens if he accidentally?
If it just once starts to say that let's decrease the complexity of this string, thinking that this is still big and now becomes smaller.
Right.
The answer, we just decrease the complexity of another long string.
But what about our Alice's budget?
No, the budget doesn't depend on which strings are. So what Sasha was explaining, that for long strings we can have, instead of keeping in the game, keeping the exact values of which strings are simple now, we just keep how many of strings of each complexity do we have. So if needed, we can just decrease the complexity of the other string with the same result.
Oh, okay. Then I don't understand at all why to use this secret at all. Do we allow a move which is just a pass move? We do not decrease anything.
Yeah, of course.
Of course. Then why Alice's Alice needs to have that secret string?
Well, Nikolai Konstantinovich, because the idea is that if Bob has a strategy that makes
No. Sorry. The answer is because this move increase an m. So this change the value of an m. So,
Коля, задай еще раз вопрос.
right?
Я не понимаю, если разрешается игрокам пасовать.
Это
Да,
не пас.
просто-
Это не
Сейчас,
пас.
дай
это
задать вопрос, подожди. Коля, задай вопрос.
Почему просто тогда Алисия не использует стратегию Боба напрямую, без секретной строки?
Нет,
Потому
это
что
не...
она дает, после стратегии Боба, получается равенство, а Алиса хочет, чтобы было не равенство.
Правильно. А потом, вот когда Алисия...
That's a very good question. And the answer, why don't we add the string later? The question
Right.
is, there is no later. The game is in limit. So Alice never knows that Bob finished the game. Bob can have strategy. When Alice does something, Bob replies. And then Alice should change many things.
But why can't we reduce it to a finite game? Actually, essentially, the game is finite. So I don't see why to prove first statement without any recursion theorem, without any computability, just for finite.
Я думаю, да, Николай Константинович прав. Да, вот в этой конечной игре, наверное, да, действительно, было бы проще сказать. Скорее всего. Наверное, нельзя, потому что, смотрите, в игре, смотрите, вы, что значит применить
English
стратегию?
translation. They don't know what are saying and what is true. Продолжайте.
Нет, здесь, если мы используем стратегию Боба, то у нас получается вот это значение nm плюс 1. И это как раз соответствует ходам Алисы и Боба. Что когда у нас не nm плюс 1, то есть неравенство. То есть в этом случае у нас входит Боб, а не Алиса. А мы не можем применять стратегию Боба, потому что у нас мы ходим тогда, когда Алиса ходит, когда у нас равенство, а не когда неравенство. Понятно?
Значит, Боб будет ходить, когда у нас неравенство. Алиса ходит, когда равенство.
Да.
Значит, мы считаем, что у нас Алиса... что Боб
Идея
выигрывает.
в том, что мы подсовываем Бобу модифицированную игру, в которой одного слова нету простого. И действуем, как он бы действовал в этой игре. Так я понимаю.
Не, я думаю все еще, что я прав. Значит, Боб выигрывает, но Алиса использует стратегию Боба. Боб добился вот этого равенства, да? И Алиса увеличивает nm на единичку.
Но после этого Боб может ответить.
Нет, а у него должен весь бюджет уже закончиться.
Почему?
Ну, потому что...
Не требуется, чтобы он выиграл, когда бюджет закончился.
If Alice has budget 2 to the power k minus 1, it can realize Kolya's idea. She can increase she can increase the number of simple strings each time when the Bob gains the equality. Because she has twice many moves. Actually, yes, if budgets differ by 2 times, Alice can do it in this way. It's simpler.
I do not understand. You mean that
each time you consider the game with equals budgets. And Bob has a winning strategy in this. Now, in the game of unequal budgets, Alice do the Bob strategy, and each time when the equality holds, she makes an additional move, declares some long string simple.
Okay, but the number of moves can be greater than to the m.
The number of moves. Why? The restriction is
because we have a polynomial time machine, and it may be to the polynomial of m.
Нет, что-то я не понимаю. Вот смотрите, игра определяется так. Очередь хода всегда того, кому эта ситуация не нравится.
Да.
Игра заканчивается, когда человек должен ходить, а у него бюджет закончился. Значит, вот у Алисы использует стратегию Боба. Значит, у другого игрока просто бюджет закончился. А у меня есть еще выбор. Вот я и выиграл.
Но может быть, в процессе, когда, может быть, ты на каждый, нет, может быть, ты на каждый ход, где он тратит рубль, отвечаешь, там тратишь 5 рублей.
Почему 5?
Я не понимаю. Мы рассматриваем игру, когда бюджет одинаковый. 2 в степени k минус 2. Значит, я выиграл. Значит, у другого игрока бюджет закончился, раз я
Подождите.
Почему?
Во-первых, у нас...
Может быть, он просто не помогает.
Подождите. У нас, во-первых, для каждого уровня свои бюджеты. У нас для каждого k есть бюджеты. И количество ходов вообще 2 в степени полинома t. Теоретическое.
Ну, хорошо. Значит, на каком-то уровне у игрока бюджет закончился. Вот на этом уровне я и способен увеличить это самое. Увеличить NM за счет этого уровня. Сейчас.
Нет, ну почему бюджет закончился? Может, просто вообще как бы он не знает, что делать, хотя деньги есть.
Да.
Нет, ну просто вот для конечной игры правильно.
Подождите, понятно, вот рассуждение, когда мы вначале добавляем, оно все-таки ясное или... оно понятно какое-то, может быть, не нравится вам, но оно понятно.
Я не понял этого рассуждения. Вы говорите, что тут не важно, какие строки именно, да? Но
это логично.
Я даже не понимаю в варианте, когда не надо указывать строк, что происходит, честно говоря. Мы секретно что-то изменяем, да? Ну, допустим, у нас просто счетчики.
Нет, почему? Счетчики. Но мы просто используем ту же самую стратегию. То есть, что такое стратегия? Это вот у нас как бы дерево игры есть, мы просто делаем то же самое. И...
в этом варианте, когда нет никакой секретной строки, это в точности то, что я говорю. Мы изменяем только счетчики,
да.
И Алиса и Боб абсолютно равнозначны. После того, как Алиса используя стратегию Боба, выиграла, она просто увеличивает там какой-то счетчик, и все. Да?
Нет, вот это вот я не понимаю, но это можно как сказать, что когда у нас... Почему мы можем использовать... мы используем стратегию Боба в этой игре. Почему мы можем использовать? Потому что Боб ходит, когда сейчас Алиса ходит, когда равенство. Вот. И, соответственно, когда... Когда в той игре у нас... Когда в этой игре у нас равенство, тогда в той игре точно не равенство. Вот. И поэтому это ход точно Боба, и мы можем использовать стратегию Боба. Вот и все.
Ну да.
Вот.
Ну, для этого нужно вот, чтобы у нас было равенство и неравенство. Равенство соответствовало неравенству в двух играх.
Ага.
И как же мы сделаем, чтобы равенство соответствовало неравенству?
Не, подождите, мы... Фух, нет, у нас как бы ситуация Алисы, она... давайте я так скажу. Значит, мы можем сказать так, что Алиса не просто может выиграть, если у Боба была выигрышная стратегия, она может добиться выигрыша в более лучшей игре. В игре, где у нее цель сделать nm+1, а у Боба сделать nm. Вот.
Угу.
Вот. Ну, точнее, nm, а у Боба nm-1.
Ну, если
Вот.
есть выигрышная стратегия у Боба в игре с равными бюджетами.
Да, да, да. Вот если у Боба есть выигрышная стратегия в игре с равными бюджетами, значит, Алиса может выиграть и в этой игре, где как бы выигрыш в этой игре, естественно, будет означать выигрыш в игре, которую мы рассматриваем. Вот и все.
Можно очень глупый вопрос?
Конечно.
А вот у Алисы же просто сильно больше бюджета получается, чем у Боба. Она не может
Да.
каждый раз, когда ей не нравится ситуация, просто добавлять какое-то новое простое слово, до которого машина не дотягивается.
Но нет, тут проблема в том, что количество ходов, вообще говоря, ограничено 2 в степени полинома t. А количество вот этого большого бюджета это всего лишь 2 в степени m. Ну, порядка 2 в степени m. И поэтому вот эта стратегия не работает. Вот.
Нет, я не понял, почему 2 в степени полинома.
Вот это я действительно не понимаю, Леш.
Ну, смотрите, у нас есть полиномиальная машина. У нее, как бы, с оракулом. Значит, это можно себе представлять как некоторое дерево полиномиальной длины, соответственно, его размер экспоненциальный. Правильно, сама вот эта машина? И каждый раз... Да.
Но это не отменяет того факта, что никогда в это дерево не зависит от строк достаточно длинных. Машина полиномиальная.
Да. Но
Поэтому
число
у нас
ходов
есть очень
ограничено
длинные строки.
бюджетом.
Нет, давайте я
числом.
попробую сказать. Дело в том, что Боб может поменять значение машины,
Для-
поменяв строчку большой сложности, m квадрат, например. Просто потому что машина может спросить почему-то строчку сложности m квадрат и поменять ответ.
Да.
Ну, какой вот мог бы быть аргумент, что каждый раз, когда Боб уменьшает строчку, делает строчку k простой, Алиса там может тоже сделать строчку k простой и таким образом поменять значение nm. Типа Боб сделал его таким, а Алиса его сделала еще больше. И поскольку у нее больше бюджета, она может это сделать. Но дело в том, что Боб может поменять значение nm, не меняя количество, может выиграть в игре, просто поменяв не nm, а выход машины, не меняя количество строк длины nm, сложности не больше m. Например, он может поменять какую-то строчку, которая спрашивает машина сложности m квадрат. Сделать ее сложность m квадрат минус 1. А как Алиса тогда как вы предлагаете при этом изменить значение nm? Ну, можно, например, опять сделать еще какую-нибудь строчку k простой, но k меньше m, поэтому вы можете это сделать не больше 2 в степени m раз. А Боб теоретически может вот эти вот свои с m квадратами действия сделать 2 в степени m
понятно. То есть
квадрате.
Алиса должна вначале изменить счетчик простых слов, потому что иначе действительно вот проблема та, которую Леша пытался объяснить, а вы объяснили еще раз.
То есть
Я
тут сила
согласен.
всего аргумента, что если Боб может гарантировать, что значение равно правильное с равными бюджетами, то Алиса потом может гарантировать, что оно на единицу меньше, чем правильное, если у него бюджет на немножко больше.
На единицу больше, чем правильно.
Я думаю, сейчас
На единицу меньше, чем правильно. Вы
на
правы,
единицу
да, на единицу.
меньше.
Да, на единицу меньше, все верно.
Мы изменили правильное, we changed the...
Да. Я.
Вот.
Хорошо.
Ну, это
Так.
только начало.
Yeah, so now we have 10 minutes for the rest.
Okay. No. I want to say the following. Okay.
But you didn't share anything now, you know this.
Ну, ладно, сейчас я... Ну, в любом случае, я могу сказать так. Значит, no, okay, the proof is initial proof that I published. It's very long and difficult, but there is some chance that you will give a simple proof, especially if you do not like this proof.
No, we will shout on you and you will invent a simpler proof because you will have no other option. This is the plan.
Okay. Let us consider another game. Let us consider the game that is initially the same. We again have some Oracle machine M. Alice wants that it is not equal to an M. Bob that it is equal to an M. And we have the same budget restrictions, the same Oracle function, but we have for k that is less than log m, we have only Bob can change, can make strings, can make strings k simple, and Alice cannot.
So Alice's budget is 0 then, right?
Yes, for this k, for very small k. But for greater than k, she has 100 for every constant greater budget than Bob. And the question, I guess, open question, is it true that for this game, Alice has a winning strategy? And it is some exercise to reduce from the statement that Alice has a winning strategy for every machine to the main theorem.
Now Alice cannot simulate Bob's strategy because she has no option to make moves on short k.
Yeah.
But wait, I still have a question about game 1. In game 1, what happens when m changes? Do we claim that Alice has a computable strategy?
Sorry.
For game 1,
actually, we play this game for particular machine M. For each machine M in enumeration of machines.
Lowercase m, not uppercase m.
Sorry?
You can computably decide the winning strategy because it's essentially really a finite game. Although there are infinitely many these long strings.
Да нет, Саша, но вы забываете, что там утверждалось, что Алиса выиграет для всех m малых.
Да.
Нет.
No, it was saying prelude and actually now.
Of course, in this case, we also have a big problem of combining different things, and maybe we somehow, as Lyosha once said, I don't know, we should somehow, instead of diagonal argument, use kind of priority type argument with some bounds on something, and it's quite delicate.
Okay.
So Yes. So, and well, I don't know. Does Alice has a winning strategy for game 2? And this is some way to solve that problem when we consider Bob moves. We consider, so when we try to prove the theorem, we say that, okay, consider Bob moves as an output of some universal decompressor. And when we consider the games like this, we just say that there is some restriction of budget, of course, and that's all. And the idea is to say that, in fact, for the optimal decompressor, there is some another restrictions in the moving of in the Bob's move. And the restriction is the following, that, for example, if we consider the last strings of the complexity at most n in the output of V, so we can enumerate the output of some optimal decompressor V, and we can say that if this is the statement, if U is greater than n and Kolmogorov complexity of U given n is constant, then after this omega n, there are at most 2 to the U minus n strings that will appear after omega n. It is clear. It is clear, the statement. It is something.
No, I am lost completely. Can you just say something? So now you try to combine these games, and can you say at least in general things? So each strategies for each game somehow will work in parallel, or there will be some active one, and then when it fails, another starts. And they are split separately. The lengths are split between games. Then just some general picture.
Well, the general picture is the following: that we need to first. So that idea, when we consider the previous games, was that we do not restrict. We do not have another restrictions in the moves of Bob, and we first need to learn something in Kolmogorov complexity, understand some statements, and after this we will consider another game with this restriction, and in this another game we can also prove that Alice has a winning strategy, like in game 1. And after this, we will prove the theorem.
But anyway, still the strategies for different games, for different machines will be combined.
Yeah.
Is it so? They will be also, each of them will have some intervals of m allocated to it.
Yeah.
And then
it's
just a basic question. So you will start every strategy at once and they work in parallel, or you start them sequentially, and when one is stopped, another is started, and then the first can start again?
Your strategy is just a universal decompressor V.
Yeah.
The strategy of Bob is fixed. Now we consider the game of Alice against the fixed strategy of Bob.
Yeah.
So, Sasha, your question has no meaning. The Bob strategy is just fix it, and Alice plays in each zone separately, of course.
So we do not restart the LS strategies. We just use each of them once in its zone, or what?
Yes.
No, sorry.
Because actually, any strategy should be computable, as I remember the previous talk. And for each zone, we have a finite game, and we can compute any strategy and the total strategy.
Well, no. Let me say that both of you are right in sense that so generally, of course, Alice has some one game that is computable, but also it is true that we some kind restart game when some move in the previous game appears. So the idea is to start another game every time when Bob outputs some string with complexity at most m. And
So I understand what you're saying like this. So if indeed we have the games when Alice can deal only with things from the segment, they can be combined. But this is not the case, and so we need to do this restarting. Yeah.
But I mean, I was thinking that also so can you say about restart? I mean, I was understanding that like the game for machines with larger indices include Alice's moves in smaller games as Bob's moves, right?
No, it is in if you can consider this if you can prove game 2, but when we restart, when we do another thing, when we restart new game after some new move appears, we just restart a new game and do not consider this as like some moves. But the problem in this situation is with budgets, that when we restart, we restarted 2 to the n times, and it is very delicate with how many budget we can we use in this local game that can be restarted. Okay, this is just some outline of the proof. Yeah. If you do not understand, it is normal.
That's a very good remark. Yeah. Very, very, very encouraging, I would say. Коля, ты что-нибудь понимаешь?
Нет.
Нет.
Леша, я тебя перестал понимать с этими рестартами. Так это что объяснение было? Так в Game 2 можно выиграть Алисе или нет? Утверждается, что есть выигрышная стратегия.
Нет, он говорит, что если бы он мог доказать, то доказательство бы упростилось. Но он не может доказать про Game 2, и поэтому вместо этого нужна какая-то хренотень.
Вот поэтому я и говорю, вот вы лучше, кто-нибудь из вас умных,
сейчас, ну подожди, если Game 2 можно выиграть, то ты просто говоришь, что вот, значит, эти игры там большим растут, и то, что в маленьких играх ходит Алиса, это как вот Боб.
Да.
В большой игре.
Да.
Сейчас, значит, в Game 2
хорошо, значит, надо просто взять и выиграть в этой игре.
Да.
Чтобы не слушать этого больше, это самое. Единственный способ спастись от этого, это выиграть Game 2. Леша, да, иначе он нас достанет. Саша, давайте, спасите нас.
Но с другой стороны, что я хочу предупредить, я почти уверен, что Allender пытался что-то очень похожее сделать, типа Game 2, Вот, и его очень раздражал этот вопрос, и поэтому, да, поэтому так и случилось.
Ну, то есть, да, нам надо помнить, что эту задачу не решил Allender, и, наверное, это объясняет, почему Леше приходится рассуждать очень хитро. Потому что если было бы более простое рассуждение, его бы Allender
Нет, ну
придумал.
хитро-то ладно, но как не какой-то хитромудрый этот самый, не то,
Ну,
что
мне
какая-то
кажется,
есть...
что если есть возможность в следующий раз начать вот с этого хитрого куска, считая, что про игру 1 мы все-таки согласились, что она есть, а дальше вот объяснить, что происходит с играми на разных зонах.
Леш, а все-таки, чтобы спастись, можно считать в Game 2, что M фиксировано?
Да, это конечная игра.
Совершенно конечная.
Да,
Для
да.
большого M, да?
Ну да.
Да.
Ага.
То есть, я так понимаю, там, если вы докажете, что есть выигрышная стратегия, то можно и вычислимо ее найти.
Ну,
Потому что
разумеется.
там
Ну, потому что она
реально...
тоже конечная игра. Что то же
Ну,
самое.
конечная игра, да, что там.
Да, ну отлично. Ну, видите,
А,
шансов.
Можно задать не математический вопрос?
Да.
Does Allender know about this solution?
He
Has he
even
seen
paid
it?
for it, for the right not to hear it, and we don't have this option.
Ну, я видел статью Леши на ЕСЗС, если Алендер
Allender
смотрит.
Allender confirmed on this page that he read and he confirmed that this is the answer, but yes.
Yeah, so there was a challenge, and so Allender agreed to pay the price. But the question whether he confirms the argument is not so obvious. No. No, of course, it's just economics. If understanding proofs is more painful than paying the amount, is easier. Okay, let me say also. So if Misha has some enthusiasm and hope, then I think we should try to continue next time.